Hello and welcome to the DnDebrief. This is the first episode where we're talking about the other first episode of Dungeons and Dragons and Science. My name's Simon and I'm joined by our caster players and our DM Ali.
Oh, hi.
So I was throwing the ball to you, Ali.
Straight to the face.
Hi. Bang!
Oh, yeah.
You get stabbed.
As always,
Try it again.
off to
No,
an
don't try.
excellent
I'll pick it up. I'll pick it up. I'm on
start.
it. Yes, that's me, the DM. 100% ready to field those awkward ball throws.
Look,
it's
been hot. It's
that-
been hay fever. No one's been sleeping
so
well.
hot.
We're all
Oh
tired.
my God. The heat.
Thankfully, some rain has come, so hopefully we are not going to be quite as out of it as we otherwise would be. But yes, we also have the two other players with me. So Emily, do you want to say hi?
Hello.
And
Anything else?
You are sorry, that's my bad. Emily, and who is your
Are we
character?
doing intros? Like, what's happening?
I play Infinite Sky 6000 serial number. I
No,
don't.
that's
And
Also, not today. You don't, because today we're not
Yeah,
doing
we're
the
in
characters,
yeah, but
you know?
in the show I play.
the other show that's the show that we're talking about.
Yeah, exactly.
and
Shamini,
Shamini,
who do you
that was
play?
your voice I just heard.
Who's there? Yes, it's me. Well, on the other show, I play Tenebris, who's a sort of drow sorcerer type person. But here,
Not that we would know this.
No. Well, it's. I was trying to keep it a secret, but it didn't work. Anyway, today I shall be playing Shamini Bundell. Hi, nice to meet you.
She sounds great.
She's
Yeah, I'm really looking
Yeah.
forward to delving
Tell
into
us about this Shamini
backstory.
Bundell. What's that? Yeah, what's
What
going on there?
powers does she have?
She multi-classes as a broadcaster
Superpowers.
and scientist.
Oh,
Nice.
Well,
nice.
For those of you
Gotta
who,
run with this
who
now.
perhaps have stumbled across this or you just haven't seen this yet, we have a website and we also have
Indeed.
our character sheets as players. So not the characters, but us as individuals. So if you'd like to learn a bit more about what we do outside of this show, then you can check out rpgeeks.co.uk. Is that correct?
.uk. Yeah.
Yep.
it has got their actual serious introductions as to like who we are and not exactly our qualifications, but you know, hi, we are actual real science people. It does say so on the website. You know.
Yeah, we
obviously.
should put that into our introductions more because it's quite.
Well, yeah.
It could be
That's what we were
mistaken for
gonna
people
do.
who clearly aren't that.
Wait, are you saying we don't know what we're doing?
That's only if we get it wrong.
Don't let on.
I'm saying it would be a mistake for someone to think that, but an easy mistake.
Folks, we really should have planned this. That's what I think.
Nah.
We did. This is the best we came up with.
This is it. It's going perfectly,
So pro,
Shamini.
so
I don't know
pro.
what the problem is.
A lovely time.
So the plan, because we have a plan, the
we do.
plan for today is to have a chat about a couple of the topics that came up, in the episode last week. Ali, could you give a very brief recap of what happened in the D&D session last week?
Yeah, so last week was the opening session. So we kind of met the world first off. So this universe where humanity is spread out across the stars, where the alliance has been formed, which is all the different systems, the human-controlled systems sort of across the galaxy, and the Armada, obviously, the Armada is its sort of military wing. And then we came to our home planet, Braxigantu, which is where we met our three characters, and the whole adventure began with those three
Dabbing.
touching down in a shuttle. Touching down in a shuttle on the outskirts, way outside the crater rim in these mountains, the McGinty Mountains, and our three characters they got into a bit of a tussle early doors.
You got into a tussle. Don't make this out like we looked for trouble.
Got into
You stabbed me.
passively. Yeah.
I
Man was
I-
stabbed on Braxigantu.
Mhm.
Who's to blame?
Yes,
No one could really
exactly.
say.
Mistakes were made and people got stabbed, but then you got out of it you met someone who got you out of it, really. A mysterious woman who took you out into this kind of beautiful, it's this just mysterious forested clearing, and took you to meet someone else, the head of the colony, and that's where we left it. So far you three have met. Do you think? Well, yeah. I'll let you guys introduce your characters if you want, like tell a bit more about them, but if it's relevant to the science. Anyway, so yeah, that's where we're at in the game.
So it's still early doors, basically. We had one event that was a particular bit of science that we would like to talk about, but with the two topics that we sort of in the bonus action that we had after the role-playing action, we sort of decided that we wanted to talk a bit about the setting, the sort of sci-fi setting that we find ourselves in, the galaxy at large, basically, not specifically Braxigantu, and something that happened with Emily's character, which you said that we should do that second. So should we hold fire on that? We want to tease people. We want to say, give them a tease. You know, what are we going to be talking about later?
Quickly, Emily.
Quickly. So my character is a terraforming droid.
Not scary. She means that she performs terraforming.
Terraforming. That was awful.
Sorry.
And so yeah, I think we might touch on a little bit of terraforming later on.
And, you know, a bit. Well, I think one of the things that we will eventually discuss in the show is kind of how we justify the powers that we are using, basically. And that was something which we did a little bit last week, and we'll probably come back to. But like I say, because it's still quite early in the show, and hopefully it's long, illustrious run that ends up with a book deal, cinema, all that kind of stuff. It's still early on, basically.
With us going to the cinema, that could be achieved.
Yeah.
One day.
Definitely a musical.
I really should have shot higher. I should have aimed for like the moon, not the Odeon.
It's
but yeah, I mean, first up, the discussion point that we thought we'd kick off with was the kind of the setting, the world, and we met the characters after. Well, was it interstellar travel that we were coming off of, Ali, or was it within Braxigantu?
No, that wasn't.
Yeah, space noise. I think. Well, you guys would know. It wasn't that. I mean, you were in a pretty janky old shuttle. You know, the smell of oil. There was, sparks. So that thing would not have made it into space, or it could have made it into space. Everybody would have died, and then the thing would have exploded. So that was not a space going shuttle.
Hard enough.
But you're totally right that, people had to get to Braxigantu initially. So, how does that happen? Can that happen?
I mean, more significantly, our universe is future this universe, right? So everyone we've met so far is humans, and the idea is that humans have colonized places. Braxigantu is not a planet in our solar system, therefore we have interstellar travel.
Yeah.
At some point in the future.
Yeah.
How's that? Question is, how
is that a thing? Could that be a thing? Is it already a thing?
How?
Has someone have I not got the memo?
Well, because I think the fundamental thing we're asking here is, like, even with future technology, is it possible, or is it conceivable? Not even necessarily it's possible, but is it conceivable that humans would travel between the different star systems? And this is something that Ali and I went away and did a little bit of research on. So I actually didn't know this. I actually had to look this up. What do you think the average separation is between stars in our galaxy?
Ooh. In our
In what? In what number? In human deaths?
Light years?
Like what?
Or...
light years. Deaths. Ali, what metric are you working to?
I've been looking through some pretty dark stuff for this particular thing. So,
so the sun is 8 light minutes away from Earth.
1 a.m.
How far's a light year? Like, is that beyond?
Oh, I really hope you wouldn't ask me that.
But I don't have a concept actually of what light year is.
I know that number. I mean, I used to know that. I'm going to Google it. Can I
Exactly
Google? Am I allowed to Google?
Yeah,
this?
I think a lot of Googling is going to happen during.
Isn't Alpha Centauri 3.4 light years away? Have I just made that out?
It's a little bit less than 4 light years away.
Ooh, damn, Ali.
Right.
It's given it to me in meters. I can't. Hang on.
So if that's our closest
miles.
sun,
A lot.
but then
our closest sun is our sun.
It's the sun to our sun.
Okay. So, but then, I mean, yes. Oh, you're totally right.
I'm technically correct. The best kind of correct.
Yeah. Where was that from?
Futurama,
Yes,
I think.
Okay, I've
It
got
is
1 light
the
year.
best kind of correct.
1 light year is apparently about 5.88 trillion miles.
Which is 150,000 astronomical units, I think.
That sounds.
And that's the
about
distance
right.
between the sun and the Earth, right?
That's, yeah.
Yeah, 1 astronomical unit is the difference between the sun and the Earth, which is I thought that was about 1.5 something, about 1.5.
150 million kilometers.
Yeah, that sounds about right.
Oh wait, so your question, Simon, was what's the average distance between stars, not what's
Yeah.
like. Ooh.
Trick question.
Oh.
Because as you get closer to the center of the galaxy, they get more and more clustered, don't they? So
Yes.
we're in the kind of backwaters where things are a bit far away.
The unfashionable spiral arm of the galaxy.
We're on the edge.
So, I was looking this up, and I learned a bunch of stuff that, even though I've been a space nut for quite a while, this is very much my jam. A lot of stuff that I didn't know before. So, like we said, the Sol, as we kind of technically call our sun, to Alpha Centauri, is about 4 light years. The typical distance between adjacent stars in the Milky Way is about 5 light years. So, in the kind of the galactic plane, sort of where we are, the unfashionable bit, it's about 5 light years. So it's actually, we're kind of lucky that we're a little bit closer than average to another star system. But in the galactic core, as you say, Ali, that separation shrinks. At the center of the galaxy, the average separation between stars is 0.04 light years.
Whoa.
So about 100 times closer together, basically.
Yeah.
What does that mean that their nighttime sort of sky looks like? Do they have the same sort of starry sky as we do, or is it sort of like
it'd be a lot more intense? And there was another galaxy, which I didn't write down the Messier number, where they worked out that the center of the galaxy was so dense that starlight would be about the same as twilight here on Earth.
Whoa.
What's
a Messier number?
I thought you meant a number that
the
was quite
galaxy.
messy. And then
Yeah,
I
so
realised
like
it-
M41, M31.
Oh, okay.
It's like the thing that you designate a galaxy
convention.
with.
Who?
This is probably my terrible.
Mr. Messier.
Mr. Messier, you must have.
The galaxy guy.
This is like
Who goes
just one
around
dude.
and names
It's,
them all.
it's named after Charles Messier. Or Messier is probably how you're supposed to pronounce it, because it's French, like mayonnaise. He's actually, wow, he was active earlier than I thought he was. He was born in 1730.
Wow,
and he
so active.
published a astronomical catalogue consisting of 110 nebula and star clusters, which became known as the Messier objects, and then we just sort of stuck with that as a system. So it'd be like Messier object 5462, whatever. So yeah, that's what I mean when I say Messier number. But yeah, there are other galaxies that would be even more densely packed. But here was the thing that I thought was really interesting, was that presumably you are familiar with the idea of a Goldilocks zone, right, around a star. So there's a region in which you're close enough that there will be liquid water on the surface of the planet, but not, and meaning that it won't be gas and it won't be frozen solid. But there is a similar concept for entire galaxies, but it's not to do with water. There is basically this idea called a galactic habitable zone, which is like a Goldilocks zone, but around the bulge of a galaxy. Because there's 2 reasons, basically. Firstly, in the center of the galaxy, the stars are so close together that there's basically lots of different things that stars give off, but particularly high energy radiation, that would mean biological life would be very unlikely to develop dead in the center of a galaxy, because it would be a hostile environment for DNA.
So on there often a lot of black, like isn't there
I was
normally
gonna say
a black
on it,
hole
isn't
in the
it?
middle of a galaxy?
In the dead center, yeah. But I mean,
Yeah.
even in that bulge around the
Right.
the supermassive black hole, there are just so many stars that there are. There's a list here that you have far more frequent local supernova, gamma ray bursts, huge amount of radiation, and
Not good.
you can even get.
So it's just a
collisions
radiation
systems.
thing.
A mostly
the
radiation
suns.
thing. But also, the outer edge of the galaxy is hypothesized to be inhospitable because there are there's too little of certain elements that you need in order to produce life, partly for the biology, so like carbon and silicon and oxygen, but also stuff like iron for terrestrial planet cores, because you need certain materials to form the core of a terrestrial planet.
Why is there not? Why aren't they there? Because
I think it's
they're not
basically
formed in stars, and
they are, but if you think about the
Types of
fact
stars.
as galaxies spin on their axis, that's the distribution of elements by how heavy they are will be tied to the rotation rate.
yeah, that makes sense.
So it's
You
like
mean
a-
you mean the light ones are getting flung out further, whereas the heavy ones sort of stay in the middle or in the near the center?
I think that was correct. Yeah, I think the problem is that you're lacking the heavier elements. as you go further and further out. So between those two factors, there's like an annulus, there's like a donut around the center of the galaxy where you can actually find life. Or, well, rather, because we have one data point, which is Earth, it's hypothesized that you're more likely to find life. But all this stuff, I'd never come across before. Which
does that mean that if you go out of your annulus and into the center, then you start to find planets that are built of of all these kind of crazy rare metals, and like there's just huge quantities of gold and platinum and stuff crashing around?
I would presume so. I have a friend who'd probably be able to tell us about that. But I think part of the problem is that a lot of what we know about exoplanets comes from stellar spectroscopy. So the light that comes from stars, you can tell about a planet's atmosphere, for example, if it passes in front of the starlight and then the atmosphere absorbs certain wavelengths. But that's a problem if your galactic core is so dense that there's going to be starlight from however many thousands or millions of stars all streaming through at the same time. So I would guess that is correct, but I feel like it'd be very difficult to actually know that for sure, because it'd be so difficult to observe it.
Right. You go, Bates.
No, I was saying ooh was I was just going ooh, how interesting. I don't have a question.
Well, the thing, like, I'm hoping that's something that we do frequently during this, though, because like even though we've all got higher degrees in science, like we all still do that sometimes. You're like, ooh, that's cool.
Are we saying there could be a planet like on the edge that could just be closer into the center that's just made of like heavy metals?
Potentially.
Like a gold planet.
I mean, the more esoteric ones that I've heard of have been stuff like potentially diamond planets.
I've heard of diamond planets.
Because it's carbon but under a huge amount of pressure, basically.
Yeah.
Ooh, diamond planet.
But
Ali, can we go to a diamond planet?
Yeah, can we get some sound design?
What are you gonna do there?
I want to bring this back round to our like universe and sorry.
Sorry, I was like, yes, do it.
And humans spreading through the cosmos, and how far they'd have to go. But I feel like the basic sort of question of sci-fi that kind of divides science fiction into two camps is there faster than light travel or not? Are people taking 5 years to go to that sun? Or, I mean, at current speeds, hundreds of years?
Right. So I looked into this because this is something that I found fascinating. The whole concept of interstellar travel has always been, like, again, a subset of my jam. So the fastest that we've ever hypothesized that we could go with current technology is using nuclear pulse propulsion. So that's basically building a spacecraft with a giant shield behind it and then detonating nuclear devices one after another. And you push yourself on the shockwaves.
Great. I mean, all rockets are anyways controlled explosions with you sat on top of them. So
yeah,
that does not sound controlled,
right? It's just an extra layer of that.
And kind of rather grandiloquently, they called it Project Daedalus, which I love as a name. But it is in breach of
ancient Greek copyright laws.
No, I think it's yeah, that definitely. I think it's the 1963 outer space treaty that like you're explicitly prohibited from having nuclear weapons in space.
Oh shit!
Really? That's cool. I didn't know that.
Glad that they covered that early on.
Yeah. Presumably, they were just like, this was in the height of the Cold War, and they were writing the treaty, and they were just like.
Can't make them in space either.
Should we say space too? Like, we don't know. The Americans are doing crazy stuff right now. So yeah.
Okay.
Wait, so how long would that take?
Right. Yeah. So the fastest speed possible that they thought would probably happen was about a tenth of the speed of light.
Oh, that's quite.
Can I ask a question?
Yes, Ali.
All right. If you've got a ship, right, and you stick a bomb on the back of it, right, and then you blow that bomb up, what kind of acceleration are you going to get into the ship? Like, how fast is that going to happen?
So I don't have figures, but what the problem is, obviously, is that would be a very short, sharp shock of acceleration. So I think the idea with Daedalus was that you basically had a shield effectively on springs, so that you distributed the shockwave would like push into the spacecraft. So it's not 0 G to 5 million g of acceleration in like a nanosecond or whatever it is. But I don't have figures for what the acceleration would be. There might actually be figures out there.
But because that's kind of because I looked into a bit of this sort of stuff, not a lot of it, but that's sort of crucial for the living aspect of it. If you've got living stuff on it, you can't accelerate too quickly because otherwise everybody dies.
I think, and a lot of the technologies that have been discussed for interstellar travel are based on this idea of relatively slow acceleration over a long period of time, rather than what we currently do, which is bucket loads of acceleration at the start, and then you kind of coast. Obviously, you have to get out of atmosphere and you have to reach escape velocity, so you do have to have a certain amount of rapid acceleration. But yeah, generally these technologies, but pulse propulsion is a bit of a weird one, I think, because it's kind of your idea of slow acceleration is like, oh, let's pop a nuke out of the back every 20 minutes, as opposed to like 15 every second or whatever.
But also like the nuke, like your first nuke, right? That's a reasonably fast acceleration. But by the time you've emptied out all your nukes and on your last nuke, right, that one's really going to kick you up the bum.
Well, it depends how much. If you think about like the density of energy, or energy density, as some people would say, of that as a fuel, it's actually really high, because the nuclear warhead doesn't actually weigh that much for how much energy it translates, because it's not a chemical reaction, it's a nuclear reaction. So, comparing the amount of energy that you get out of detonating it compared to detonating a bunch of TNT, for example, like an equivalent amount of energy being released, but in a chemical reaction, the mass is much less.
But I just meant that, like, at the beginning, right, you've got 100 bombs on your spacecraft, which basically makes up most of the weight of your spacecraft. So the first bomb you let off, you're going to have a huge amount of momentum to overcome. But by the time you let off your last bomb, you're going to be incredibly light, and you're just basically going to be like a feather riding on the back of like a hurricane.
Well, that's what I mean. Like, because the energy density is so high, the relative change in mass of your ship actually wouldn't be that great compared to if you were powering it with a chemical reaction, which is kind of like what all rocketry is based on.
See.
It's the Tsiolkovsky equation, which is why you separate stuff.
How long is it taking me? Am I there yet?
Sorry, yeah.
There yet, Simon? Are we at Raxagantu yet? Like...
You should have gone to the loo before we left for Alpha Centauri. So basically, if you went at a tenth the speed of light, then you would get to Alpha Centauri in about 40 or 50 years.
That's not so bad.
So within a human lifetime. But,
yeah.
That's actually way better than I thought somehow.
What is that? What's there?
Well, you've got to go there to find out.
Get there.
It's a trinary star system. There's 3 stars, and there's a possibility of habitable planets there, maybe. But I don't know. Have to go there to find out.
Because I was sort of looking up the habitable star systems, and there's a lot of stuff about the TRAPPIST one, but then when it comes to Alpha Centauri, I never really have any idea of how habitable it is. Like, why aren't we talking about that?
I think theories have gone back and forth on it, to be honest. I've read variously that it wouldn't be habitable because it's constantly bombarded by stuff from 3 different suns, even if one of them is like very small. And then some people saying that, well, it's actually probably a very stable orbit in the middle of all of them. I actually don't know what the state of knowledge is at the moment. It's certainly not habitable in the sense of it's Earth-like. I feel like when people talk about habitability of like the TRAPPIST system, that's because there are planets which are roughly Earth-like. Whereas I think with Alpha Centauri, it's more a question of how stable the orbit is and how stable the star is, I think. But also it's close. You're going to be like, we could probably make it over there. Like, we'll make it work.
Proxima b, one of the exoplanets, is subject to stellar wind pressures of more than 2,000 times those of the Earth from the solar wind.
That would be bad.
Wow.
Wikipedia says its habitability has not yet been definitively established.
We don't know. That's what that is.
No.
Mars is a death trap, but people are still like, cool, let's go live on Mars. But there's a lot of shit you have to do to live on Mars. So
yes,
we'll get into that later.
We will get to that in just a little bit.
But
people are pretty keen to get off Earth. It's a funny one.
We're ruining it.
It's easier just to start with a new planet.
By the time we can get off Earth and live on another planet, we should be able to hopefully fix Earth. Is my personal thought. So that's.
Will we though?
No, we'll all be dead.
Will we?
Oh.
So the other thing, just to kind of wrap up this discussion, I guess, so that's basically what we think at the moment. There is the possibility. So the question comes down to how fast can you go, right? Like as long as you're willing to expend human casualties, even if you went on conventional rockets, you'd get there. You wouldn't be alive, but you'd get there.
Yeah, but you need someone alive to get there, right?
So you're saying you have like a ship of corpses which you fire at Alpha Centauri. That's the plan.
And hooray, we've put people in another solar system.
or you freeze them, and you do suspended animation as a
and
topic.
They're still corpses.
Yeah, there probably are still corpses.
Ones.
A slightly relevant thing that I was reading today is about how many people you would need to send to avoid them all being wiped out by plague. Like, did you read this, Ali? What's the like minimum population like safe?
You tell me. I think I read that one.
I believe it was somewhere between 10 and 40,000.
What?
Between 10?
I've got a very different number.
Is that wrong?
10,000 and 40,000.
Oh, sorry, 10,000.
Oh,
Is that not right?
I was like, that is an error bar and a half.
Inbred.
Sorry, not literally 10,000.
I've come
What
out.
did you get?
My guys were a bit more optimistic.
Oh.
They were saying you could get away with 98.
98 people?
So wait, is this for epidemiological reasons? Is this for
To
disease?
not get wiped out all in one go.
No, my guys were like, so I found a paper which I have to say has not been published in a real journal yet. It's on Arxiv, which is fine. It's a good place to put things, but it has not been peer reviewed. So they were saying,
let's peer review it now.
The question is, if you build a sort of generational ship, right? Which is instead of saying, right, we just freeze everything and have robots just look after us until we get there. That's one way of doing it. The other way would be, we're all going to live on it and we're going to be a big happy community and everybody's going to get on for however many hundreds of years we have to do this for.
Yeah.
So they were saying, if you take that model, the generational ship, what's the minimum number of people you need in it so that they can survive without becoming so inbred that everybody dies.
Oh, okay.
Ouch.
Right.
I know, ouch, right? And they quite confidently were like 98 for 100% chance of survival.
I guess there's a lot of historical precedent here, right? It's like putting colonies out in places like Australia, for example. Like there are plenty of cases through history where colonies had to be set up, and I guess they looked at which ones were successful.
I don't know, but like Australia was like a load of you were prisoners, weren't you? It wasn't like you were taking the kind of perfect ratio of men to women. It gets pretty dark, this paper, because there's a lot of stuff about like bearing children and things that's not great. But I think they were just doing it from a mathematical, like if you look at the amount of genetic variance and, how when it's safe for two related people to have children and all that kind of stuff. There's lots of sort of charts saying if you're identical twins, not safe. If you are like second cousins, kind of safe.
And then it's the Iceland's problem. Like, Iceland has this app.
Yeah.
The Faroe Islands have it as well, because there's just like so.
Ooh, I know Iceland does for sure. I'm sure other island communities have this too. But like,
tell us about the app.
So the app is that if you want to date somebody, you basically put in your details and their details, and it will tell you how closely related you are. Because the population is so small, and over time, there's just so much interbreeding that goes on. That you are only so many steps removed from anybody you could meet. So it will tell you, basically, should you have children with this person? Is it kind of genetically safe to do so?
Are you allowed to marry a second cousin? That's the question. Because there's like loads of like places where people marry their second cousins all the time, and it's fine.
I think we can marry our second cousins if we want.
But if you're already
in the UK,
already on an island where everyone is already close together, I wonder if that makes a difference. Like.
Yeah. Do you mean you're actively encouraged to?
No, I just mean you're more likely to be actually more genetically similar than
each step down like the family tree is introducing more genetic variability, right, in a larger population than in a smaller population.
Yeah, exactly. Yeah.
According to my Google search, first cousins can marry in the UK.
Oh.
First cousins.
First cousins.
Wow.
Well, that's the next 6 months sorted. So yeah, and the same
I have
guys,
a lot of questions about where this campaign is going, Ali.
It's going to deal with some themes that I want to get into.
No.
So these guys, they count the first thing. I keep calling them guys. So I think it is men. I think it's 2 men who did. I'll have to check. Maybe it's 4 people. Anyway, I'll have to check who writes. But anyway, so they write this paper and then they say 98 people, is your minimum, and then and then it ends up being around 400 or something. It sort of flatlines at 400 after a few generations, and that's enough to kind of deal with space plague and stuff going wrong. And they model this all with the they say, all right, we've made a Monte Carlo simulation model.
You rolled a bunch of dice. That's what that means.
Yeah, exactly.
What we do.
I was like, oh wow, the Monte Carlo
Everything
simulation.
you
That
do.
must have known an awful lot about space. They must have spent a long time doing that. But no,
What is it? No, but what is it actually? Like, as in, where does it come from? How do you know?
it's
that
a
that's what it is?
probabilistic model. So they're saying basically you input a load of probabilities. So like, how likely would it be for me to get space tuberculosis? I'm going to say 0.1, and then you put that in, and then you sort of do that for everything you can think of, and then you just calculate it loads and loads and loads of times and see what the numbers end up looking like.
It's named after the casino. Like the algorithm was invented during the Manhattan Project. I recently learned. What? Yeah, it was because it was on basically on the primitive computers they had, like the Maniac. They could only run so many calculations. So when they had something really complicated, like calculating the yield of a device, you could work out like a geometric approach to it, and then do a Monte Carlo estimation of that by saying, basically putting random points in your phase space volume of like all the possible answers, and then count the number of times it's within the geometry that you're looking for versus the number of times it's outside. And then that ratio tells you what percentage of the volume your answer occupies, and so how big it is.
Yes.
Yeah.
Yeah.
Ooh.
It makes more sense when you write it in equations. But it's like, okay, imagine it like this: if you wanted to work out if you wanted to work out what pi equaled, then you could draw a square and then put a circle in that square, and then say its unit radius, and then put random points in that square. And if they are in the circle, you count them as being in the circle, right? I know if you do that enough times, you will get a proportion of them in that circle, that if it's like a unit square, that will tell you what the area of the circle is within, right?
Yeah.
And so that will tell you what pi is, because if it's unit radius, then the area is pi times r squared.
That is clever. So you're basically making a fraction, which you can then use to go and do something with. Oh
What's
God,
that
my
related
brain.
To? Wow.
Where the Monte Carlo algorithm comes from.
Oh yeah, the Monte Carlo thing.
Where did we start?
Oh yeah, God,
So
way back
faster
there.
than light travel.
Yeah, faster than light travel. Okay.
But
We have it. So basically,
Relationships.
all the stuff that we've talked about up until now has been trying to get around the fact that we're limited to the speed of light by relativity. Thanks, Einstein. But you can potentially get up to something like 90% the speed of light, they reckon, with antimatter based rockets. So annihilating matter instead of a chemical reaction, and that's incredibly energy efficient. So obviously you can only get a certain fraction of that as like available kinetic energy. And what's interesting is if you do get to 90% of the speed of light, that you actually do have to worry about stuff like time dilation, or equivalently Lorentz contraction. So relativistic effects, basically, that mean that if you're traveling at 90% of the speed of light, you perceive time, of course, to go exactly the same speed it always has. But what happens is you perceive the distance to be 2.3 roughly times less than it actually is, because relativity is weird like that.
Yeah.
But so I've got
That's
some
kind of
clues from Ali's narration, which is when we were on the planet, and Infinity was like, "What year is it?" No one knew. Everyone only knew the year from colonization. What was it, AC or something? No, it wasn't AC. Whatever it was.
It was
colonization.
Just 278C or something.
Yeah. So that to me implies that the kind of colonization that we're kind of talking about in our sci-fi world, they don't like maintain that much sort of connection. There's not a lot of like, so it doesn't matter about relativistic effects. It doesn't matter like what year it is or what time it is when you arrive, because they're just kind of blasting people out into space, and once you're out there, you're not going to go pop home for a holiday. Like that's it. That's where you live now.
Because
you're still going to get.
If you were to do that,
communications,
you could have like a central lighthouse on Earth, say, that just put out like a pulse with this is the year on Earth, and then that's going at the same speed everywhere. So you could be like, right, that's like our central clock. That's what we measure everything relative to.
Cool.
If you knew where Earth was or even
If you still
knew
had
what
an
it
Earth.
was.
If you still had, but also, what if you
yeah.
didn't care?
Yeah.
What if it was decentralized?
Yeah. But
Um,
then
yeah,
we have,
like
we have an
Cornwall.
alliance. So what is this alliance doing? And is it timekeeping?
They
Is
bad
timekeeping the
people.
main
And
job
if it isn't
of the
timekeeping, then
alliance?
what the hell is it doing?
What are you doing if you're not telling us the
Okay.
year?
And then,
so
sorry, just because we were just to wrap this up, basically, we were talking about faster than light travel. Haven't even got to faster than light travel yet, because it depends who you ask about whether that is possible or not. According to relativity, conventional velocity cannot exceed the speed of light, but there are a variety of kind of tricks aware that you can get around it. One of which would be like going through a wormhole, which is the classic. You bend a piece of paper, put the pencil through it, and you're touching 2 points in space-time that every movie does that has a wormhole in it. The one that's more interesting to me, at least, is the actual concept of a warp drive, which is basically like Star Trek technology, right? That
Run on dilithium crystals and warp plasma.
Yeah,
Is it all
exactly.
real? Is everything real?
Well, there is a concept called the Alcubierre drive, which is effectively like, you can think of it as like space peristalsis. So what it does is it creates a local bubble of space-time that you don't move relative to, and then it moves that bubble by effectively contracting the space in front of you and expanding the space behind you. Which is,
oh my god, this is so useful for when I get like tree stride at higher levels as a druid, and I'm like, we can travel anywhere, but technically we can't until we can science it. Thank you.
but the problem with that is, you can contract space-time with mass. That's what energy and mass do. But expanding it requires a negative mass, basically, which you'd need to do with some kind of exotic material that we haven't met yet. It might not be possible, but like if you could construct something that has a negative energy density, negative mass to it, then you could create these bubbles in space-time, and you could, in theory, we think, go faster than light. But
So that's like an anti-Higgs boson you'd need.
I think that's one way of thinking about it. Yeah, that's when you start to lose me, when you actually start talking about these potential theories of exotic matter. I don't know enough to understand them.
I know enough to know I don't understand them.
Yeah.
Ali, at what point in this game are we going to be allowed to be like, oh yes, it's this particle that is a new particle that's not been found yet, to explain stuff?
Well, I would say, you could give it. You could certainly try to say that and see what that would. Yeah.
Noted.
I don't want to. Yeah, I feel like. Well, okay. Well, I've. So, Sty, while you were looking at like whether you could actually sort of shoot the thing fast enough to get to where you wanted to go, I was thinking what would happen to people on board while that was happening, which is
the people.
pretty much all bad.
Yeah.
Yeah.
People, Simon.
Like-
Remember people?
I remember people.
They're the
yeah.
stabby ones. Don't go near them.
Yeah.
The ones that stab.
Don't make eye contact. Don't make eye contact.
They stab and dig.
Yeah, exactly. That was this is my strategy.
The first mention of digging, by the way. We didn't even mention that up until now.
We've done so well.
Yeah, digging. But I sort of feel like, we've done a lot of space travel. We can always come back to, what's going to be like aboard the ship. But do you guys, Bates and Sharmini, do you want to
Blather about
put us up with some
terraforming.
terraforming stuff?
Yeah.
Yeah.
Look it up for
Did we
facts
want
about
to do? What we?
terraforming.
This is an Emily question. Were we doing a break before we did all of that, or are we ploughing for?
I think we'll probably play for. We think we'll probably go for about an hour to an hour and a half, we said. So I feel like that's probably about the right amount of time to go through without a break. Probably.
It's a lot of science.
It's a lecture and a half, but we swear sometimes. That's so it's more interesting.
And don't really know what we're talking about some of the time.
Yeah, exactly.
Look it up on
So like
Wikipedia
some of the
time.
lectures you probably went to at undergrad.
Often distance ourselves from the content.
If any one of you fall asleep in the audience, we'll just go in and like balance chalk on your head. Did you guys?
Could we?
Did your lecturers have chalk, or did they have whiteboard?
No.
Any of mine did.
No, just a PowerPoint. Gosh.
Oh yeah, I got chalk.
Because you're at Oxford, Simon.
They had people come in to like, it was their jobs to come and clean the boards, which I always thought was very weird, because they were like these big they were the things that were on like carousels, so you pulled them down.
Yeah. Oh, it was always good when someone moved one of those down and there was a load of stuff underneath it.
Yeah.
Like, what is this?
Yeah, they're like, don't look.
What's the do?
You're not allowed to know that yet.
Yeah. It's a bit of knowledge. Quickly, bring the rubbing person.
Bring the rubbers.
Yeah, there's a lot of claxons going on. Cover your eyes, children.
Terraforming.
Sorry. Yes.
Oh yeah. Oh, actually, can we ask chat? Can we talk to chat? Is that
About
can we have a chat
terraforming?
break?
More than welcome to
Yeah.
talk
So
chat.
so the people who are watching live on Twitch, obviously if you're listening to us as a podcast, then come and watch us live. We're Thursdays, every other Thursday on twitch.tv/Dr. Simon Clark at 7 p.m. UK time, and you can be interacted with like this. But yeah, go ahead.
Oh, so I'm actually technologically incapable of even opening
You're
chat.
not even on chat.
I thought you were looking at chat, and that's why you said it,
It's
Ali.
not in chat.
I can't open it. I
doesn't know what's
tried, and
happening.
Twitch just said, do you want to be a fan? And then I just thought, I want to open chat. And then I panicked, and I just thought, look, if I try and open chat now, I've lost control. So I'm gonna
I've
not.
been all over the Alcubierre drive thing.
Yeah.
Yeah.
All
All right,
about
I'm
that
gonna
for
try
you.
this out. I'm gonna try it.
that happened.
But talk
That's
amongst yourselves.
faster
So
than
Ali's
travel
internet is
or whatever.
working this week, which is
Yeah.
nice.
Yeah.
But
Unfor-
we
unfortunately,
haven't
so-
yet taught him how to use a computer.
His internet is working, as are his boomer genes.
That's low. That is low.
Put this on TikTok,
Alistair.
Germany. I want this moment to be immortalized.
Yes,
And then we'll have
will.
to explain
The
to
youth
Ali.
shall put it on TikTok.
Ali will have to explain what TikTok is to Ali.
Oh right. Well, if I just enter the chat room now, I can't get the chat from before.
Oh no, you can't.
No, you
It's
can't,
gone
no.
now. Sorry.
Oh.
But what did you want to ask?
So I'm just going to close this. That was a
Oh, that
dream
was
that's
all-
dead now.
Oh, that was really sad.
Well,
What
Goodbye,
did you,
chat. I
what
barely
did you
knew
want to
you.
ask? I
They're
felt we
trying
need to
tell
pay
you
off
about
this
faster
segment
than light
now.
travel. The faster than light travel. They're trying.
Hmm.
You're ignoring them. It's sad.
Well, I
F the
can't.
chat. Yeah.
I can't hear you, chat. Chat louder. Chat louder.
I want to talk about terraforming because otherwise
Yeah.
we're never gonna.
Okay.
But okay, Simon, just keep an eye on chat, and then Ali, you could be the go-between for Ali.
What am I looking out for? Am I meant to be like,
don't
you know,
know.
making sure they, if they make an interesting point, I'll bring it up.
Yeah.
Yes.
Like that.
Okay.
Right.
Right. So terraforming. So Bates, your character
Mm.
is a droid
Yeah.
who was sent to terraform a planet. I must say,
Yep.
the most interesting thing about this for me is I was reading up about terraforming, and they're all like, "We're going to need asteroids. We're going to need huge amounts of materials. We're going to need to like build a space umbrella." And then like I'm like, "Or there's Infinity Sky 6000
Or
serial
a
number."
robot. 8691. No,
You're a druid.
a droid. This is.
How did you come?
I've been trying to make
Stop there.
a
You just
droid,
got there.
droid.
Welcome, Simon.
You're a
Welcome.
D&D, a druid and droid.
Ooh.
Oh my God!
That's
Oh!
very well like that, yeah. No, that's good.
There we go.
Yeah.
This is how we come up with our names for everything, pretty much. It's just conversations like this.
So yeah, do you have an idea for how a single android creature, or like is that the deal? Is the deal that they send this one sort of unit out there?
No.
Do you know? No, is it secret?
No.
You're looking really shifty right
It's
now.
kind
You can't
of-
tell me.
Well, no, I can. No, I don't think this is a spoiler. Ali, is this a spoiler?
I don't want
I'm gonna look
spoilers for
to
the,
Ali.
for the adventure.
I didn't. and
She's
they don't
not
say-
the only one. Let's put it that way.
Yeah. Okay, that's fair. I mean,
She's not the only one.
Yeah.
So, I just kind of want to move it away from the actual thing. So, terraforming. Currently, we can't terraform a
What
planet.
is terraforming? Should we
Really?
define terraforming?
Yeah.
What is
No.
terraforming?
What is
Yeah.
terraforming? I don't think I found a good
It's-
explanation.
Terraforming is the process of making a planet or a moon or a body in space habitable for humans, but it's making it fully habitable. So we're not talking about going and like constructing a dome on Mars that everyone can go and sit in and be fine as long as they don't step outside. It is making the planet itself a home for life.
And perhaps we should mention that is specifically life as we know it. Like it's a
Yes.
it's a very Earth-centric idea.
Yes, very Earth-centric. So our version of plants, carbon-based creatures and breathing oxygen for humans, which I think is, and that is terraforming, right? You wouldn't ever say you were terraforming a planet to make a different life form that we're not aware of.
Well, no, I more meant that, like, what if we discovered a planet that had life of some form that we didn't recognize, and then we were just like, no, we're going to make this actually like our kind of planet. And
Yeah, that would be terraforming.
yeah, but it would also be
'cause
extermination.
Terra is Earth, isn't it? In Latin?
Yes, I think
Agreed.
it's Latin.
Sure, yeah, Latin. So I think so the main things we need are obviously there has to be oxygen, otherwise we die. There has to be the temperature has to be good. It's that Goldilocks zone that we spoke about. Yeah, again, it can't be too hot or we'll burn. It can't be too cold or we'll freeze. And then there's a lot of sort of other things to do with like the atmosphere and pressure, and general not dying is always good.
When I looked it up, there's a lot of things.
A lot.
So I was kind of like, oh yeah, you just kind of get the oxygen good and grow some plants. But like the number of variables that you can have on planets in space that have to be just right, because we've evolved just on Earth where like it's exactly this range of temperature, like the day-night cycle, because the day-night cycle affects the temperature, because if the day's too long, it gets really hot, and if the night's too long, it gets really cold. So suddenly it's not just about the temperature of the planet, it's like orbit and things, and I'm like, oh no, anything wrong, we'll die.
Well, so hang on, if you had a planet which was like it was all good except it had a day that was a year long, right? Could you, in theory, attach basically space ropes to it and rockets to those ropes and just spin the fucker up?
Like a Beyblade.
For some reason, in my research on terraforming, that was not proposed as a reasonable scientific solution to things, but maybe.
I'm just trying to think. Yeah,
the amount of energy you require would be beyond astronomical.
Well, wouldn't it be literally astronomical? I think that's probably exactly the right
what
word.
You could do is you could just migrate all year. You could just follow the
sun.
Follow the right conditions. Like,
you could stay right on the line in between, and then just
also becomes one of your
and then go to sleep on the other.
One of your ring planets. What's the one? What do you call them?
Ring planets.
It's like the habitable zone is a ring around the planet.
Oh, tidally locked planets. Yeah, if the day is equal to 1 year, then you get a habitable ring. Eyeball planet might be what you're searching for, which is if it's like a water planet that's a tidally locked planet.
Right.
Because it's ice all over, and then you just got
the sun all the time.
Yeah.
So hang on. So how much of this can you actually do? You know, like what's possible to change?
There's a lot of ideas. So basically, at the moment, everything is it's a little bit Mars centric. There's a little bit of chat about Venus, a little bit of chat about Europa and Titan, but pretty much.
Who is chatting about Venus?
People are. They think that they're like, if we can cool down Venus, great, let's do it. It's going to be fantastic.
Carl Sagan spin up the slow moving one, but we can cool down Venus.
Yeah. So Carl Sagan back in 1961 argued for the use of genetically engineered bacteria to transform carbon in the atmosphere into organic molecules. However, this was rendered impractical due to the subsequent discovery of sulfuric acid in Venus's clouds.
It's not just a temperature thing.
Yeah, but there's sulfuric acid bacteria at the bottom of the sea. That's not a biggie.
But like, this is the whole problem, though, of like, if you send in one biological element to clear out one element of the environment, you've introduced another problem. And then we end up with like snakes on Venus to capture the mice that we introduced to capture the mice who we introduced to capture the bacteria.
No, so one of the reasons that Carl Sagan wanted to get the algae, whatever, to get the carbon and turn it into organic molecules wasn't just to have organic molecules. It's because the atmosphere of Venus is full of carbon dioxide, which is rubbish, but it's also just really full. So it's at like 91 atmospheres of pressure. It's like 91 times the pressure of us. And the real problem with Venus, and like I was looking up, how do we terraform Venus? And everyone, like the main solution other than cooling it down is like, how do we get rid of all this atmosphere? Like it needs to go. Like we need to
put it on Mars, then we can solve two problems at once. If we could take the atmosphere from Venus,
see that suggested.
Put it on. I don't think that's a real suggestion. That's very much an Emily's suggestion.
Put it in a bag of holes.
Find a way.
Very much an evidence.
And if people could just get to work on that, scientists, off you go.
Have you ever done a siphon? Where you through a hose and then the water.
And
you've got one guy.
Earth can be in the middle.
On Mars.
With his thumb over the end of the pipe, and it's like, right, take that.
Yeah. If we all point our vacuum cleaners at Venus at once,
we have to be on Mars to do that. Or
No.
We use Earth as like the midpoint, right?
What? And then halfway through, you're like, go from blow to suck now.
No, from suck to blow.
Yeah, the
and
other
then
way
you blow it all towards Mars.
Been blowing this whole time.
And I'm sure that would definitely work. And there's definitely not a million other reasons that wouldn't work. So,
Can I tell you my favourite plan for getting the atmosphere off Venus? So there were plans involving getting the carbon and turning it into like carbonates and like, oh, let's like just like dig up a load of the entire crust and then it'll just sort of precipitate out of the air. But you know, that's too difficult. So my favourite suggestions were they just physically could take the atmosphere and like fire it into space, or use space elevators, or like these sort of like I can't remember what they're called, but like electromagnetically powered rocket lifter things, and like literally just like get the atmosphere, just like.
how are you getting the atmosphere? Like, what are they doing?
You just get it. You don't put all over the details, mate. You
like
get
a big
the atmosphere.
like a big
With your
jar.
Hoover. We've got the Hoover.
Oh,
suggestion.
sorry, I forgot about
And
the
then
Hoover.
you launch the Hoover into space.
Towards Mars.
Less atmosphere.
You launch
The whole
Hoover,
Hoover,
not
not,
just the
even
back.
the content. Yeah, the whole Hoover. Right, that's another one full. It's just
that was my favourite thing that I
I thought the problem with the atmosphere thing was a sort of gravitational issue, in that, you know, you couldn't hold on to the atmosphere. So how come Venus, which is smaller than Earth, is holding on to so much?
It's about
I
the
believe
same
it's
size.
more to do with the magnetosphere.
Magnetosphere.
Mars' magnetosphere is gone because its iron core stopped. Doesn't stop. Well, it cooled and solidified, so it no longer has a magnetosphere like Earth, which is what keeps like the solar wind from blowing all our atmosphere away. So Mars, I think it loses. I used to know this number. It's like part of a pound every day of its atmosphere just gets stripped away by solar winds. That could be wrong. It's something like that number.
Solar winds
Someone else keeps talking.
are constant, right? We've got this constant stream of particles coming out of the sun, which is why like comets' tails always point away from the sun. I think that's what sort of clued someone in to be like, aha, solar winds. And the reason that we don't sort of notice this on Earth is because the Earth sort of acts like a giant sort of dipole magnet. It's got sort of magnetic fields around it. They interact with the solar winds and create this magnetosphere, which is kind of sort of like a protective bubble around Earth. Now, if Mars had one of them, the atmosphere on Mars would be able to like accumulate again rather than constantly getting blown off. So there was
Could we
yeah.
attach ropes to the center
Oh,
of Mars?
yes, there we go.
And then
Yeah.
There are always ropes. No, this is the giant space umbrella plan. It's not the ropes plan.
Or the giant
okay,
space
sorry.
magnet plan.
Well, yeah, giant space magnet plan.
I like
Which
the magnet.
I also
the sound
liked
of
because it
this.
was a very serious man from Sirius, NASA's Planetary Science Division, who said, right, all you got to do is put a giant magnet next to Mars, but between Mars and the sun.
Yeah.
Because the magnet has its own magnetosphere, and Mars will therefore be in the shade of
this
the
magnet.
magnetic umbrella. Right,
Oh,
it'll be like-
so it's the same thing. The
And
umbrella.
you could put it at a Lagrange point as well, like with a stable.
What's that?
Yeah.
A Lagrange point
What's a
between.
Lagrange?
It's basically the point where, crudely, the gravitational attraction between two bodies is equal. So between Mars, for example, and the Sun, I mean, Earth has them, and they have names. There's like L1, L2, L3, where you can put something and it will basically stay there relative to those two objects. So it's like a stable satellite, basically.
And so you've got this magnet, which is basically sort of shielding Mars from all this solar wind. Can you do anything useful with the solar wind? There must be a huge quantity of energy there.
I don't know.
The density of it, though, is so small because it's a vast amount of energy, but it's being radiated throughout the entire solar system. I'm not actually sure if you could do anything useful. To get a sense of the amount of energy that's in it, you just have to look at the aurora. Like the actual density of the aurora is indicative of how little energy there is in the solar wind.
Yeah, I guess if you go up there, you're not suddenly like exploded into a nuclear bomb, are you? You're just flying through a little lights.
Well, and you have other problems like suffocating.
Yeah, you're flying over the North Pole. You don't know how you got there.
Someone from chat was asking about tardigrades. Tardigrades being the adorable little
Water
bears.
cuddly bears.
I've got a fact about this.
Survive.
This is a lot of my
everything.
research.
What was this all about tardigrades? Well, I was
Mainly,
going to say
yeah.
this sort of brings us around
They
background
survive
to using
everywhere.
using living organisms for terraforming, which I want to ask you about, Bates. But Ali, tardigrades,
No.
we love them.
Tardigrades,
No,
yeah.
you do you, and then I'll tardigrade at the end. You know, I saved my tardigrades. But I'm not.
So there's also, I think it's cyanobacteria, how you pronounce it.
Yeah.
So they're believed to have been potentially what sort of began life on Earth, and they can, through photosynthesis, they create oxygen. So they basically could Infinite Sky have the stem cells for loads of these little bacteria and just go debag her.
The
seeds.
bacteria.
But did you say debag?
That's what Ali said last time. This is not a me thing.
Are bacteria not in a way?
I'm just
all
happy
kind
that
of
you
stem cells?
adopted it.
Oh, that's a good point.
You can't. A stem cell is like it's
Yeah, it can't be a
pluripotent,
bacteria.
so it can't be.
Couldn't turn
Yeah,
into
that's
a
a good point.
bacteria. That's a really good point.
Oh, could
Oh.
it turn into a bacteria? Could it subtract
it?
out a load of its own genes, like boot out a load of genes into the?
Well, I
turn
mean,
this?
there's a
No,
whole problem with
I'm just
the
saying, if it's a
pluripotent thing.
bacteria, it can't be a stem cell. Is what I'm saying. Because
Yeah,
stem
no,
But a
cells-
stem
you're
cell
right.
could become a bacteria if it just booted all the stuff out.
Don't think it could.
Why not?
Oh, you don't make eukaryotic cells into prokaryotes. This is also would not help us in our terraforming efforts.
If we can make the bacteria, it might.
So wait,
Okay, so
what are the
maybe she's got a
bacteria
little
doing?
bag of.
Making-
So they can convert. It's carbon dioxide? Oh my god, I've written notes and they're useless.
Yeah.
Yeah, I believe it
Oh,
comes
it's
upside into oxygen.
Converting Earth's early
Oxygen.
atmosphere of methane, ammonia, and other gases into the composition it sustains today. So they transform gases.
Which I should just very briefly point out was like one of the most traumatic events in the history of Earth. Like some people in atmospheric scientists call it the oxygen holocaust event, because it was the extinction of like over 90% of life on Earth, because most of it evolved to tolerate low oxygen environments, and oxygen was
It's crazy,
toxic.
isn't it?
That's
It's
mad.
very
And
toxic.
and if you think like oxygen, before that, you could light a match on Earth and it would just go out, right? But oxygen is incredibly reactive, right? And it just sort of eats away, it rusts things, it blows up, it does all sorts of stuff. It's heinous.
And it's one of the reasons why we think so much multicellular life developed then, because like cells enclosed other cells to protect them from oxygen.
Oh, that's
Really?
I
That's
don't
one
know.
theory.
Really?
I've heard, yeah.
It's like, I protect you from the evil.
it's such
oxygen.
Yeah, it's like band together.
theory.
It's like everybody like pointing outwards with their little cellular guns. Like,
A lot, the Alamo. It's
Yeah.
the Alamo lines.
yeah, it's a wagon train. All the cells just go around in a circle.
Get the mitochondria behind the horses. Right, hang on.
But that kind of thing. Sorry, I was
No,
just
you
saying
go.
that's terraforming, right? Like the bacteria did it. Why can't we?
But it
Yeah.
took billions
Yeah.
of years. Like it wasn't a
It took a
quick
while.
event.
Yeah. So this is the
can
thing.
speed it up.
Quick terraforming,
Oh, yeah.
not going to happen. Hundreds and thousands of years, they think we could potentially, if we can work
To
out
change
how
an
it works,
atmosphere.
to change a whole atmosphere and planet. But that brings us to Braxigantu. We don't know what Braxigantu was like before it was terraformed, because there might have been nothing wrong with it. It just might have been lacking any like form of life. We don't know, and I don't think Ali's going to tell us.
No.
But
Secrets.
look, he's just
Look
staring.
at his little innocent little face.
Oh,
Do I know?
I mean,
It's a rich and fully realised
That's a good
world
question.
that Ali knows everything about, and I will continue to believe this.
he knows exactly where
His
it sits
notes just
in the
say
universe, in the
dig
galaxy.
question mark.
Just jumping back to cyanobacteria quickly, one of the interesting things I found, there was a bit of research recently that found that they work at a lot lower light for the photosynthesis than previously thought. So they used to think that they could go to about 700 nanometers and then they were done. But they found that they could actually go quite far into the red spectrum of light and 750 nanometers, which is a bit darker. But they were still creating the process, which sort of brings us around to like, could they exist on much darker planets that maybe we thought life couldn't exist on, but actually they could be doing their work right now and creating.
I mean, and the other point is that like this is all based on life as we know it, because obviously that's where you start
Yeah.
looking. Like, could a biologist here please explain to me how life could be different if it? I don't know. How could life be fundamentally different? Like if it was based on a different thing from carbon, for example.
Silicon-based life.
Silicon is the one that always gets bandied around,
But it's
isn't
just
it?
because it's got 4 bonds, right? It's just because a carbon atom has 4 bonds and therefore can make long chains.
Likes to grab things.
And so does silicon. I feel like
Is that the only reason that they,
I don't know, that's all
they
like,
go
yeah.
with silicon?
I think there's a film called
Understand.
Evolution where that happens, but
Ah.
yeah.
Yeah, I wonder, are there other elements that feasibly.
I mean, but the crucial thing is, you have to have that. With what makes our carbon-based life so useful is that you have the chain, and then you can stick something on the top of it with one bond and something on the bottom of it with another bond, which means that you can make all these complicated things.
And then some of them can stick their arms out the side and hold on to something else. And
yeah, exactly. But that doesn't mean that you couldn't have a sort of much simpler, like I'm talking way out of turn here. I do not know. But then, you can get you can get. Come back to me.
I was worried your internet had gone again, Ali.
The problem with could there be life out there that's so unimaginably different from ours? And it's like, I don't know, I can't imagine it. That's kind of the definition.
That's the point.
Yeah.
Yeah.
Well,
but also,
there's the story of the guy who loses his keys on a dark night, right, on a road, and somebody finds him looking for his keys underneath the lamp, like the street lamp. And they say, "Oh, where did you drop the keys?" And he's like, "I don't know, but it was somewhere around here." And they think, "Oh, it wasn't under the lamp?" They go, "No, but I can see here, so I'll start searching here." And I feel like that's kind of the situation we're in, because at least you know where you're at with life as we know it. We can't actually imagine something so fundamentally different.
Just seen a really cool question in Twitch chat that I might
do it.
Go for it.
In Chernobyl, they have found fungus that use radiosynthesis to grow. Could we use that to put plants on Mars? I don't know what radiosynthesis is.
That sounds like you're converting radiation to usable energy.
Right.
Yeah.
Is that what that means?
But what kind of radiation? Like alpha, gamma, beta, what?
Do you know why you always keep your fly zipped up when you visit Ukraine? Because otherwise Chernobyl fall off.
Mm-hmm.
Oh.
Yeah.
Shouldn't it be Chernobyl fall out?
Yeah, I think. Yeah.
Ooh. Oh.
Well,
The thing about using
I was trying to buy time for you to Google this.
You've bought time.
Everybody just turned around and was like, "What?"
But surely, so the thing about bacteria and all sorts, have using wildly different energy sources, is as opposed to almost all life on Earth is at some point based on the sun, right? Or comes back to the sun, unless it's a few weird bacteria somewhere. So presumably the issue with the issue with colonizing Mars is Mars gets plenty of sunlight. There wouldn't be an issue with an energy source. I suppose it might be a way of dealing with the fact that there's lots of excess radiation, but it wouldn't help us live there. But it does link to a future chat, which I will chat about my idea for my characters.
We know very little about your character.
Backstory relating to.
Hold your character horses there, Shamini. I've got some melanin chat that I've got to lay on you all immediately before I just completely forget what I'm even looking at.
Is this radiosynthesis?
This is radiosynthesis. So there is a paper in 2014 where these guys. Are they guys? No, they're not.
Folks.
These people.
Say folks.
These folks. Oh my god. Oh god, everything's going wrong. So yeah, these folks.
Chat being
they have this. They found this fungus, and it contains this chemical called melanin, which we have in our skin anyway. It's a pigment, and they said that ionizing radiation was changing the electron spin resonance of melanin. I don't know what that is.
Electron spin resonance. Oh dear.
I know what those terms mean in isolation, but not how they combine.
Okay. Yes,
so I don't know what that is, but they said that basically the radiation can change that, and then that led to an increased ability of the fungus to produce NADH, which is one of the molecules involved in respiration.
What does the D stand for?
What do the other letters stand for?
Well, I assume that was sodium deuterium hydrogen or something.
No, it's
not.
I'll tell you what it is.
That's you're thinking chemistry there.
Oh, sorry.
Oh no, it's offering me supplements. You can buy anything.
Nicotinamide adenine dinucleotide.
Oh,
there you go.
Okay. Oh, someone in chat was also right there.
Sorry, Shams. I'm done with my. It's interesting paper. I'm done.
Wow. So I think we've solved all the problems of terraforming and faster than light travel quite easily.
Sorted, which is nice.
Tardigrades.
Was there anything else?
Tardigrades.
Oh yeah. Okay, this is awesome. Right. So one of the massive issues with just sort of cycling back to getting humans in the tin can to the newly terraformed world. One of the things that happens if you're an astronaut and you go up into space is that you basically start suffering from various health issues. And one of them is cardiovascular sort of degeneration, like the cells in your blood vessels start to basically, mutate, and that's not good. And then some people did some other sort of tests where they took brain slices. They took brains from rats and they irradiated these rats, and then they cut their brains up and they had a look at what was going on in the brains, and they were like, the activity appears to be a little bit different than it should be. So the idea is that if you get exposed to loads of radiation in space because you're not being shielded by the Earth's magnetosphere, then you are more likely to develop all sorts of different diseases, which is where the tardigrades come in. Because the tardigrades, you can desiccate, you can suck all the water out of a tardigrade and you can leave it on the side of a spaceship and it will survive in space.
Okay, no, sorry.
They are. I think they're cute. I think they're quite cute. Yeah.
Imagine this tiny little bear trapped to the side of a spacecraft, just roaring into the void.
Except
the
instead of a
spacecraft
head, it's got a gaping black hole.
Yeah, it's just as it's being yeeted out of the atmosphere. Like, its little paws clawing onto the side of the metal. I will have my vengeance! As it's frozen.
Anyway, yeah. But tardigrades have a set of genes which make their DNA highly resistant to ionizing radiation. So that's partly how they survive. They can sit up there and their DNA doesn't get just smashed up in the same way.
What's
so
different?
Why did they evolve this? Because they didn't know they were going to space. This is suspicious.
Or did they?
I think they did. Tardigrades are the big bad.
What if tardigrades are the last survivors of an interstellar civilization?
That's what I was thinking.
I like it.
Yeah.
A giant tardigrade.
Yeah.
Gotta write
this.
this.
Otherwise known as just
Make
a bear.
it a dragon. That could be the dragon.
Oh my god! Has anybody shot a bear into space? Can they survive? Because that could be the.
I mean, they probably have.
I've got one word for you there, which is Russia.
Yeah, I mean, they probably have.
They probably did, and it went very badly, and they were like, "We will never tell anyone about this."
What they have done, which is tangentially related, is try to breed a bunch of animals in space, because there's a question about whether embryos can develop in zero gravity. And we haven't done it with humans, so we don't know. But mice don't seem to like it. Like,
oh, really?
The nematodes, they seem to be fine. Like it's this big unknown question. But it did get me wondering, because that's sort of like zero gravity, and it seems to be like kind of probably doable. But I did wonder whether if we went and settled on a planet with a very different gravity, which there's loads of other health sort of effects too, could literal like embryo development and cell differentiation and replication be disruptive?
Because life is so finely tuned for the environment that we find ourselves in on Earth.
Exactly.
Like, what if we can't live anywhere other than here?
Well, that's why you have to terraform to basically be Earth.
Terraform.
But you can't change the gravity. You know, you can't.
But there's a difference between saying.
Probably could.
I mean,
there's a difference between saying that you function best at a very, very kind of tiny range, but we actually can survive over quite a broad range.
But for a lifetime and have children, like.
Yeah, kids are squishy.
My hope was, and again talking about terraforming and talking about all the things that can be wrong, is surely if we've got either our faster than light travel or like the commitment to go everywhere, surely there are enough exoplanets out there that are close enough that we could find with the right orbital period, the right gravity.
Well, and also, could we just create, little domes on planets for a bit as stopgaps?
If you just misfire and you've got to the wrong, oh god, it's
that's
the one
the
next
Mars
door,
plan, though, isn't it?
That is the Mars plan.
Can I finish the tardigrade story just before I forget? The end, because that's interesting about tardigrades. But what's super interesting is that some crazy guy, he is a guy, when took the most took the tardigrade who was the most resistant to radiation, took the gene that was responsible for that and whacked it into a load of human cells and then irradiated those cells and was like, boom, these cells survive now. So the next step is like, right, well, astronauts, could we just bang them full of tardigrade DNA? And then, they could be a little bit weird looking, but
mutants.
maybe they'll...
Space vaccine. If you want to go to space, you've got to have your space vaccine.
I bet NASA are thinking that because they tested it on their twins. They sent one person, they had two, they had the twins, and they sent
Kelly
one
twins.
into space.
I've met
Yeah,
them.
exactly.
Have you?
And oh my god,
that's really cool.
Yeah,
both.
I went to NASA when one of them, I think it was Mark, was in space and landed the space shuttle, and like we were at the landing, and like his brother was there, and we were meant to be going out for dinner with his brother like that evening, and then Mark came into the restaurant we were at, and he was like, I wasn't doing anything at home, I was just bored. Like he'd been in space that morning.
Oh my god!
Oh my god, that's cool.
So,
yeah, because they were testing like whether they age differently and things. Well,
yeah. So for people who possibly, just to briefly explain, who might not know who these people are, they are Scott and Mark Kelly are two identical twins who are both astronauts. And they did a year-long experiment where Scott was the commander of the International Space Station, and they basically monitored him and his brother, and they saw how they evolved, how their lives changed, but on a biological level differently. Not in terms of like their relationships, like it was purely like how are your cells doing?
Oh, not how
How are
you
my
feeling?
cells doing? No, how are your cells doing, idiot? But they tested vaccines. That was one of the things they did. So NASA's the long game.
To change the subject, chat are having a fantastic discussion about whether
Space
you can get an
erections.
erection in space.
Spirections.
I read a lot about the sperm being fine. Don't worry, everyone. Sperm is fine in space, but I didn't read about the erections. But
I'll take the plunge. I will look up space erections now.
Well, the conclusion seems
I'm
to
taking
be
the hit.
Someone's already done it, and they, the blood is still
has
fine.
been done.
Yeah, your erections are fine. We think
It's a pressure thing, right? It's like
I don't think it cares about gravity.
Testosterone levels may drop in space, which could contribute to erectile dysfunction. Apparently, this is all from chat. This is Cass. Thank you, Cass.
Citation needed. It was basically what we should say. People could be putting absolute nonsense in chat. Like if you go to chat, Chernobyl fall off, and we'll be like, we'll just read it out.
Fall out.
I did that one.
Fall out is better.
Oh yeah, Chernobyl fall out. Yeah.
Yes,
That was the joke, Simon.
I thought it would fall off
damn
because
it.
you were going somewhere that's so irradiated that your knob will fall off.
I think that is kind of funny.
Yeah, but also your hair
if
could
you
fall
fall
out,
out, it's even
and
better.
you could have some fallout. It's just many levels.
Yes, I'm a human peanut. Thank you, chat. I'm king of the peanuts. which just not a D&D related fact, but we were looking this up beforehand. The word for peanut in French and Spanish comes, which is Ali,
Cacahuete.
which comes from Nahuatl, which was the language spoken in the I think it was Aztec. It was a Mesoamerican language that was then a word adopted by European settlers. So as opposed to presumably English speakers were like, there's a nut that has a P in it. It will be a peanut.
Shut up, you peanut. We'll call it a cacahuete and be happy.
We spent a lot of time before the stream started just saying cacahuete to each other. So if you want to know how we get in the zone,
Warm-ups.
especially as we were all like whispering it into our microphones.
So that feels like a natural sort of end to the sciencey discussion.
Oh god, there was so much more to talk about, but I think
that bodes well because we've got so many more weeks hopefully of doing this. We've got the way for people who perhaps have just joined. This is the D&D brief where we're talking about the science. Next week we're going back to the D&D action where we're going to have our next couple of hours of the campaign on Braxigantu with our characters, and that will provide some more jumping off points to have discussions like this. So we're going to be alternating on weeks, which you can watch live on Twitch, or you can listen to on a podcast, or watch on our YouTube. All the links will be down on the below in the description if you're watching this on YouTube or in our podcast feed. Yeah, Ali, can you give us any hint? No, I don't want to ask you for any hints. Actually,
No spoilers.
no spoilers.
Just no.
What year is it?
If I knew that, things could have turned out very, very differently. That man who attacked you, he was just confused and scared. Didn't know when it was.
Also, I don't know if Ali can give us spoilers. Maybe Ali needs spoilers from us about what the heck our characters are going to do next.
Yeah, dear God, what is going to happen?
Unpredictable chaos.
Barely got into that room.
We missed Sandy, we just wanted to hang out with Sandy in the forest.
You did. Sandy had to be dispatched. You're not seeing her again.
Can I point out, if Entangle had worked, if that spell had worked, it would have been so cool. Because
I only worked on one of them.
One person. There were
Same
like
me.
6 of you, and I tried to get everyone just
to
hold
get
it up so
everyone.
I could
That
be
would
like,
have
talk
been
to me.
really nice.
But no,
That would have been great.
Everyone rolled really well.
I wish that would have worked.
Yeah, there was no middle ground in that
Really cool.
episode. We were rolling really high or really badly.
Yeah.
So,
Yeah, get that sweet grey area.
but with that, there will be next week at the same time, so 7 o'clock UK time, some more D&D action here. And if you haven't watched or listened to the first episode, that is available on all the previously mentioned on our podcast and on video. But we will say there are a couple of technical issues, which, as far as we can tell, we have been fixed today. We actually haven't had any issues with Ali's internet in particular. It's all been quite smooth and synced.
But jinx it in the last 10 seconds.
Yeah, it'll all fall apart now.
Dig.
Goodbye, my friends.
But so if you do want to go back and catch up, then you can do, but we will provide a recap next episode of what happened.
I would also say I think the podcast is slightly easier to listen to.
Emily Bates edited the podcast.
I wasn't going to say that, but thank you,
nice and
Shamini. I did. I took out a lot of the
Put a lot of
pauses
work
where Ali's
to help
delay
fix it.
was messing everything up.
Thank you, Emily Bates. We appreciate it.
I was being broadcast from one of the moons of Braxigantu. That's why.
Couldn't have done it without you all. Go download the podcast anyway. Available on all regular podcast apps. Probably not all of them, but a lot of them.
Most of them. If there's one that we don't have, let us know.
Yeah, let us know.
We might do something about it. With that, I think that's probably a good point to draw a close to things. Thank you guys for joining me. Thank you all of Emily and Shamini and Ali for joining for this discussion, because I had a fun time just dorking out about stuff.
Oh, that's great.
There's so much more to say.
There is. I mean, and who knows what we'll talk about next week, frankly. 2 weeks even. There's so many ways you could go with this world. There's the characters, there's the setting itself, there's D&D as a whole, like the powers that we're using. Who knows? I get the impression that next week something will happen. It'll be like, oh, so we're talking about that then. Like, I need to go and do an hour of research on, monks or whatever.
Science of monks.
I mean, within our world and how their powers work, I met.
There's some cool stuff on mindfulness science.
Yeah, John Kabat-Zinn did a bunch of stuff, didn't he?
Yeah. Let's hold it.
Sorry,
for another time.
Keep that powder dry. Save the gold.
Yeah.
Thank you for joining. Those of you who've been on Twitch, and if you've been listening to this on the podcast or watching on YouTube, then I hope you enjoyed. Do let us know. If you did enjoy the episode, then you can do all the normal things like rating the podcast, liking the video, and you can also tell people, your D&D group perhaps, about this experiment that we're doing, trying to fuse science communication with D&D adventuring. And that means a great deal, basically. We'd love to see this project grow and evolve with your lots of feedback, and as our characters and our adventure grows. For those of you, somebody in chat is just asking, the podcast is called Dungeons and Dragons and Science. I think that would be the easiest way to find it. We're probably the first result for all of that.
Yeah, or RPGeeks.
Yeah, that's kind of like our troop's name. And then the project is Dungeons and Dragons and Science. With that, thank you very much for watching. We'll be back next week. Goodbye, I guess.
Goodbye.
Goodbye, I guess.
Bye, I guess.
Bye, I guess.
Professionals.
I guess.
Good night, everybody.
Always professional.